This is the second video on how to calculate the length of a missing side in a right angle triangle using our trigonometry. It's very important, if you haven't watched the first video, watch that first before you watch this one. We're going to go through the same steps that we did in the first video, looking at those examples, but these have got a little bit of a wrinkle in the tail. So we're going to go through the steps, and when we get that far we'll talk through the differences. Okay, but first thing first, we're going to go through the same steps. We are going to label up the sides of our triangle. So we've got our hypotenuse, the angle that is opposite to the 32 degrees is going to be my 4, and the third side is my adjacent next to my angle of 32 degrees. We're going to work out which two of those three sides we're interested in. So we've been given the opposite side, 4 centimetres. We've been asked to calculate the length of the hypotenuse, our variable x, and we don't know A, and we've not been asked to work it out, not interested in A. So any of the ratios that have got the adjacent in I can get rid of. So we can get rid of the cosine ratio. Tan's also got adjacent in, so I can get rid of that. And now I'm going to be using my sine ratio. So sine of A is equal to the opposite over the hypotenuse, and we're going to write the formula down. We're then going to substitute our values in. So what have we got? We've got an angle of 32 degrees. So sine of 32 degrees is equal to my opposite side, which is 4, divided by my hypotenuse, which is my variable x. What makes this question different to the two that we've looked at previously is instead of having our variable on the numerator in the fraction, we've got it on the bottom, and that's going to make it much more difficult to deal with. We're going to have to do a little bit of algebra. Okay, what I've got is I've got 4 divided by x. I want to get rid of x from the bottom of my fraction. So I want to do the opposite of dividing by x. I want to multiply both sides of my equation by x. So I'm going to get x times sine of 32 is equal to 4. And if I divide by x and multiply by x, I'm going to get back with what I started my value for. So I've already got rid of the x out of the fraction. It's looking a little bit better, but I also now want to get rid of this multiply by sine 32. So I want to do the opposite operation of multiplying by sine 32, which is to divide by sine 32. So x is equal to 4 divided by sine of 32. I can put that into my calculator. It can do the work for me. So we have got 4 divided by sine function of 32 degrees, close off the bracket, press equals, and I've got a value of x equals 7.5, and I'm going to put 5 to 2 decimal places. And I'm going to put my units on centimetres. We're working in centimetres for this question. Okay. I can also have a look at this question by going back to my triangles. For these questions, when we've got the variable in the denominator, it's a lot easier to use the triangles, and let's have a look and see how that works. So in this case, we've been asked to work out the value of the hypotenuse, my x value up here. So my variable is x, we're trying to work out the hypotenuse. So I want to cover up h in my triangle, and it's going to tell me to find the h, I'm going to divide the opposite by the sine. So h is equal to O divided by the sine. Let's write that down. So my hypotenuse is equal to opposite divided by sine. And I can substitute my values. Is 4 centimetres divided by the sine of my angle, which is 32 degrees. So 4 over the sine of 32 degrees. The same calculation that we did over here and put into the calculator to get 7.55 centimetres. So it's equal to 7.55 centimetres. Just going to pause there. We're going to have a look at another example. This time we're just going to stick with the triangles and see how that works. We're going to go through the same steps as normal. I'm going to mark up, label up my triangle. So we've got my hypotenuse opposite my right angle. We have got the side that's opposite the angle we're interested in. side that I can't touch if I'm stood in my room, and I've got my adjacent side, 9 centimetres. We're going to work out which two sides we're interested in. So we're trying to work out the hypotenuse, my value x. We've been given the adjacent, so we're interested in the A, but we're not interested in the opposite side. We've not been given it, and we've not been asked to work out the value. So we can get rid of the two ratios that have got the opposite side in. So we can get rid of sine, it's got the O in, and we can get rid of the tan ratio. Not interested in those. We're going to be working with our cos ratio. Okay, which value are we trying to find out? We're trying to find out our hypotenuse, h. So x is equal to the hypotenuse. So I'm going to cover up the hypotenuse in my triangle and then have a look at the values I've got left. So it's going to tell me that the hypotenuse is equal to the adjacent divided by the tan. So to work out the h, I cover it up. It tells me it's equal to the adjacent side divided by the cos of the angle. So let's write that down. So my hypotenuse is equal to the adjacent side divided by the cos. We can then substitute our values. So the h is my value x, my variable I'm trying to solve for. It's equal to my adjacent side, which is 9 centimetres, divided by the cosine of the angle, cos of 35 degrees. Again, we can put that into our calculator. Let's see what we get. So we've got 9 divided by cos of 35, and that's equal to 10.99 centimetres. When we do these questions, it's really important that we do a sense check. So in this particular case, we've been given the base length, 9 centimetres, and we've been asked to work out the hypotenuse, the longest side, this value of x. So I'm looking for a value that's going to be bigger than 9. The longest side has got to be bigger than the other two sides. So x has got to be bigger than 9 centimetres. We've got a value that's 10.99, so it's bigger than 9. I'm comfortable that I've got the right value. If you come up with a value out of your calculator and you've got something like 6 centimetres that's less than one of the two shorter sides, you know you've gone wrong. You know you need to work through your triangle. You've probably got your ratio the opposite way up. Okay, so always do that sense check. I'm looking for a value that's bigger than 9, works in this case. Okay, the third example that we're going to have a look at, we're going to go through the same steps as before. We're going to mark up sides of the triangle. So we've got our hypotenuse, opposite the angle, and we've got our adjacent sides. So we are interested in the opposite side. We've been given the length, 6 centimetres. We're trying to work out the adjacent side, our x. So we need the A. We're not interested this time in the hypotenuse. So we don't know its length and we've not been asked to work it out. Let's cross it out, our h. We can get rid of our two ratios that have got the hypotenuse in, they've got h in. So I can get rid of sine, it's got the h in, and I can get rid of the cosine, it's also got a hypotenuse in. I'm going to be using my tan ratio, opposite over adjacent. But in this particular case, we're trying to work out A. You know that x, the value we're trying to solve, is my adjacent side. So I'm going to cover up my adjacent, and to do that, to work out that value, it's going to tell me I'm going to need to take my opposite side and divide it by the tangent. So to work out A, cover it up, what's it tell me? I need to take my O and divide it by my tangent. So we've got my A is equal to, so cover it up, O divided by tan. O divided by tan A. Substitute those values in. We've got adjacent side is equal to x, the value that we're trying to solve for, and it's equal to my opposite side, which is 6 centimetres, divided by the tan of 42 degrees. 6 divided by tan 42. We can pop that into our calculator. So we've got 6 divided by tan of 42 degrees. Hit the equals, and we've got 6.66. So x is equal to 6.66 centimetres. We can still do our sense check on this one. It's a little bit more difficult because this time we don't know what the longest side is. It's one of the we've been given one of the shorter sides. We've just worked out the other shorter side. In this case though, the angle 42 degrees, a little bit less than 45, so I would expect this side here to be a little bit shorter than my X value. A little bit less than 6.66, comfortable it passes my sense check.